All right, so what I wanted to talk about today is how using the Teledyne technology has made something in our industry very valuable. And it's some technology that's been around since the 70s and some technology that's been around over 50 years with some of the acoustic release connectors that you guys use already. In particular, I want to talk about drilling. Now, everybody's familiar with a drilling rig, probably, right? These big structures that go offshore and they drill. Well, they're attached to the seabed by anchors, some of them. Some of them are dynamically positioned and they just stay there by themselves. But what we do as InterMoor is we put these out and we anchor them offshore. And there's two basic ways to do this. Conventionally, which means it kind of has its own components and you go out and you place the anchor down, or we can go out and put everything in place first and then come back in and hook up the rig. So there's different reasons for doing those, whether there's something nearby, there's infrastructure on the seabed, if it's deep water like this is showing. So that's kind of the basics. So I want everybody to get their head around kind of what this means for mooring a rig. We're basically just trying to keep the rig on station. And most of the time, as you can see here, there's several different ways to do that. If you take a look at this top one, these are more conventional type moorings, or we call them catenary moorings. And that's like up over in Alaska, offshore Newfoundland, the UK, North Sea sector. A lot of chain, and it's usually all on the rig, and you just run the anchors out. In the Gulf of Mexico is where you get more of the deep water, Southeast Asia, some of Australia. So there's different types of moorings that we use. And this is all important because in those different regions, there's different drivers for having to release. So, and I'll come back to that in a little bit. So today, what we're talking about is, we call this the InterMoor release. It's a mooring connector that has a remote disconnection capability. So we can drop the mooring lines for various reasons. And then it's an instant release, and then it's also not too difficult to go back in and reconnect. So as you can see here at the bottom, there's several reasons. So there's storms, blowouts, icebergs, or even just operational efficiency. So when you talk about wanting to disconnect, these are some of the technologies that have been around for a long time. So you have a quick release like a tire, where it's just a mechanical thing. You have some of these rockets. Those are quick releases where they're holding something in place until it has to take off so it doesn't fall over. We've built something similar to this actually on a DP rig. It was a DP rig in 2002 that just came out. Government didn't trust it to work on its own, so they said, hey, we want you to put 4 moorings on there. So they came to us and we said, okay, well, we can do that, but we have to put this big monstrosity piece of equipment, basically like this, and mechanically pull a pin and like a big pelican hook release it when they wanted to get away. So it was actually back in 2002 we started looking at, we know there's acoustic releases, how big can we make these? And we talked to subsea connector manufacturers and said, hey, can you release under load? And we were always, even back in 2002, having the discussions of how can we release under load. And actually, this product here has been around since the 70s. And they were using these over in Alaska. In this connection, if you remember that drawing of the shallow water anchors, this connection was very close to the anchor. And so in Alaska, with the ice flows, they would acoustically release so that they could pull the rig out quite quickly. Now, having it that close to the anchor did cause some problems because acoustics and mud and those types of issues came about. But all in all, I think they worked okay. So the InterMoor release came about because we knew there needed to be something better. And so we went to our sister company, SRP, which, by the way, I have to give credit to Johnny Shield. Hi, Johnny, if you ever see this. He's the one that put this together, and he's really the brains behind the product itself. So as InterMoor, we're the mooring guys. We throw the stuff in the water. We go move the rigs. We just tell them, this is what we need. This is what has to happen in the industry to keep things moving. So it's really based on three things. The Rocksteady, which is a proven connector already that SRP has designed, and they manufacture these for, you know, big wind farm type applications to small pipe applications. And it's basically wellhead type technology for the connection, which you'll see later. And then, of course, Teledyne's acoustic modem was the key part of all of this, which is very exciting for us. And then this needle valve release actuator. So he needed something quite compact that can mechanically drive the actual release mechanism. So just taking a look at what's out there, this is the interim release here. And then so if you look at the brake load, right? So this is the maximum you can pull on this connector. And what's important here is the earlier versions of these were only right around the smaller chain size brake limits. So with these bigger rigs, bigger storms, bigger weather criteria, we've had to make things bigger and more robust. So you can see that the interim release is right there at 900 tons with the other ones, the other newer ones. I might say, so if you look at the yellow one, that's kind of that the old one that's been around since the 70s, which has basically stayed the same up until they upgraded, which is in that orange right there. And then this green one is a kind of a new player that's hasn't been offshore with it yet, I don't think. But so anyway, so there's a few more available now. And so you can see the release capacity. This is one of the most exciting things. We can release under the brake load of the connector, which is incredible. And where that comes into play is, you know, if you're having an iceberg coming down on you, you've got 4 days to where you have to pick up anchors. That's typically how long it takes to pick up anchors in the conventional way. And so it doesn't seem like a whole lot of time, but that's a long time. And so does the iceberg care if there's already a storm? No, it's coming at you no matter what. So the point is the tension levels, you know, if you're in a storm, you're already getting to these 300-400 tension levels to where you may not be able to release. And so one of the key things we told Johnny at SRP was we need to be able to release at a much higher load, because, you know, that was always concerning to us that, hey, you've got an iceberg coming, the guys have, you know, let it come in that zone, that 4-day zone, and now you're in a storm. So, you know, then you have to go to all your contingencies and all of that, which, you know, you don't want to do. And then, of course, the weight. So that was the other thing. So I said we need to make everything bigger and more robust and everything. Well, SRP came up with a connector, as you can see here, that's about 1/4 of the size of the other ones. And that's a big deal, because when you're handling this in rough seas, getting it deployed, I mean, there's a big difference between handling one of these versus this. And that's the real life size. That's the prototype. So you can see that's about as big as it is. So leveraging the Teledyne technology. So this was the exciting part, and I'm not going to claim to be an expert in this part at all, so I know there's a lot of people from Teledyne here, so questions can be directed to them on this part. But basically what we want to do, and they looked around at some other options, and but it was key to us to use Teledyne for one reason being is that, oops, sorry, there's this little red flashing, is it flashing? Yeah. So this release pin is identical to what you guys use on the Benthos connector, I believe. And so that really was the enabler for us to confidently keep that acoustic part in there. And then the other thing was they had to make this needle valve work that will actually mechanically drive the connection, which you'll see in a little bit. So we wanted a trusted one. I mean, this technology has been around for quite a while. I read the brochure yesterday, and I think it said it's been used over 50 years. So, you know, it's very robust, and we didn't have to do much of anything except integrate it into the release command on the connector. And so the exciting part is the performance. This is the advantage. This is why I'm here. This is to say, hey, Teledyne is the best in the business at what they do, and this is why. So look at the range. So the range, you know, is over 5,000 meters. The water depth goes over 3,000 meters. And the battery life, we can make up to 5 years. Whereas now, the industry standard has been 9 months, and it costs a lot of money to extend that to 18 months. And so now we're already at 5 years now. But the water depth in the range, I mean, that's huge because, I mean, that's, when you're doing the mooring system design, I mean, sometimes you might have to put it in deep water. We might have to put it closer to the anchor, which could be 6, 7, 8,000 feet. It really just depends on what's around, what infrastructure's around, and what the case is. So this just shows my favorite benefit of using Teledyne. So one of the things, we've used these connectors. When we owned some of the old ones, and we still own them, and we've used them recently, and most of the time we have some problems with the communications, whether that's from noise from the rig, if there's thrusters, you get some shadowing effect. And so a lot of times the communication wasn't quite good enough to talk to each one individually. So I think it already played. You saw the video, so basically with the Teledyne modem, once you talk to one, you're basically effectively talking to all of them. And so to us, this is one of the most exciting things about the new connector, is that we don't have to rely on single communication lines. It's like a network down there. So that's a huge advantage. So this is just a schematic kind of showing how it works. So you've got the acoustic signal coming down, and then it actuates, and the gas goes through the actuator, and then it pushes this over center line locking pin mechanism. And we have a redundancy on that, so you could actually use an ROV in a push-pull mechanism if there is a problem. Now, I have to tell you, I called Johnny. I've got the email right here because I wanted an answer. I said, well, what if somebody says, what happens if the modem fails? And he said, I don't know. Ask them what happens if their steering wheel falls off when they're driving, right? So it's a matter of going through the failure mode mechanisms and understanding how to prevent those from happening. And so that's what we've done here. So yeah, it is a single modem on there, but we have that networking capability, so we know our comms aren't just a single source. So this just kind of shows the exploded view, and this is where we worked very close with them, because at first this thing was a monster, and they had all of these modems and things on the outside, and I said, that's not going to last 5 minutes offshore, Johnny. You got to do something with that. And so he built all these kind of roll bar cages all over the thing, and it looked like a NASCAR, you know, sponsored piece of equipment, right? And so they really went to work, and they got this down to where it's basically machined like an engine, right? So there's no real voids, there's no containers. I mean, it's just a big block of forged steel, and they just made enough room to put everything in. So you got the valve cartridge, the fill vent, of course the batteries, and then the modem. So all of these things kind of fit nicely inside. And this just shows the actual connection. So this is kind of based on subsea technology, you know, installing trees and other connections like that with the fingers on there, so, and the receptacles. So you can see it just kind of comes in. And normally what we would do, for this particular case, we would make this connection on deck, right, and then deploy this over. We can preset this on the seabed, right, in like a mud mat, and then come in and make a connection. So there's a lot of different ways we can do that. And so this is the part showing you can see right here, this is what makes the release. So we have the modem that sends the signal to the actuator. That will turn the motor and then click this hinge over. And then right here is where the ROV could come in and use a push-pull mechanism and kind of do the drive itself if there is an issue. So that's the mandrel. Oh, they call that the toggle, sorry. I forgot to click a bunch. So that shows the locks over center. It's kind of like one of those funny hinge things where you push it and push it and push it, and then it goes all the way. That's how this design works. And there's an indicator there. So this will repeat. It kind of shows, you can see it coming up, and then it just flops into place there. And this is just another view showing it from the end cap. And these were during all of our prototype testing, which we only had to build one. So where are we now? So we're basically through all the qualification testing, and this is the test bed. Like to point out, that's the ABS man, and that's the D&V guy. So we have our we're all good to go there. So we have let's see, 700-ton proof load, 25 tests on design verification. And that's when we started making a few little changes. And then we did the 300-ton acoustic, a 300-ton manual releases several times, and then 900-ton acoustic release, right? So this is the exciting part. So this is the 300-ton release. $300 tons right there. So, and then get ready for it. This is the big one. That's at 900 tons. We actually did a little bit of damage to the test bed. So, so anyway, so we're very excited about this. It's a connector that's on the market now. It's not a sales pitch. This is where we are. It's double capacity and about a quarter of the weight. It's D&V ABS type approved. 5-year battery life, and of course, Teledyne has really pushed this over the edge in technology for being able to use this everywhere. And we can have simultaneous releases. I mean, with Teledyne, I forgot to mention that we can release 1 at a time. We can program it to release 4. So a lot of flexibility. So with that, I think I actually went over time. Okay.
Teledyne Marine. Everywhere you look.